excuse the really bad writing, it does say sound on that, and this homework is all about sound representation. So you'll see you have 5 panels with 5 descriptions, and you will have to read them and put them into the correct order. As well as doing that, you have to draw a little explanation of what actually occurs at that particular stage. So I'm just going to run through the sound quite quickly. So what we'll have is an analog wave, excuse the terribly bad drawing, which is picked up by a microphone, not an ice cream cone as it might look like. So this signal, which is detected by the microphone, will be in an analog format, which is impossible to be represented exactly that way in a digital manner. So what has to happen is it uses an A to D converter to convert this analog symbol into a digital format that can be stored in a computer system. So what I have is this analog converter to digital converter rather, which has a constant rate that it samples at, that is occurs which is measured in hertz. Sorry, I'm trying to think of the right words. And it occurs regularly, however dictated by the sampling rate. So let's just say, for example, that each of these little markers are when samples have to be taken. So a higher sampling rate would mean we require more samples, so more of these would occur on the timeline. It requires more data, but the final sound that we store would be much more similar to the original sound. Now, if we had a really low sample depth, and say, for example, we only had 2 different readings, that would mean that every one of these samples, it would either sample it here or here. So we would have this kind of odd changing all the time, depending where it is, or often not changing, which is nothing like the original sound whatsoever. What we really is a high sample rate, which is in hertz, as well as depth, and the more bits that we have to store each sample, the more closely we can recreate the analog sound when it's played out by storing more data about it in a digital format. So just to kind of reiterate, we've got a sound that's produced, an analog sound, which is detected by something like a microphone, converted to a digital format, produced by some source originally, which could be someone singing, for example, which is then picked up by a microphone, and that analog signal is converted to digital. The sample rate dictates how regularly, how often that we see what level the sound is at, what that analog signal is doing at that particular time. And how much data we can store about it is determined by the sample depth. Now, if you've got a higher sample depth, we can more accurately represent the sound at that particular sample. If you've got a higher sampling rate, we take more samples and more often. Again, both of those things mean that the sound we reproduce is more like the original, but they also require more memory. And then all of those samples are stored and saved into backend storage on the device, which allows you to play it back again.